Hello and welcome back. This part of the visual data, we're talking about what happens if the data is not in a nice, easy group form for you. So for the previous example, we had Monday through Friday, so you had 7 days, so it made for 7 easy intervals. So there's a couple of new definitions we have to introduce here. We have something called a continuous variable, and that's a variable that can have any value, and the key word there is any value within a given range. So what that means is you can have values with decimals or fractions. So examples would be height, weight, temp. So you could be 22.5 centimeters tall, or you could be 250.3 kilograms, and so on and so forth. The discrete variable is the counterpart to the continuous variable, and it can have only whole or integer. And I throw integer in there. There's probably only a few cases where that's true, but you can only have whole numbers or values. So basically the key there with the discrete is you can have no decimals. And that includes people, tickets, cars. Okay, so just two more definitions to make sure we understand. Okay, so grouping data. So what happens if our data has too many different entries? So with the example of the days, you only had 7 to deal with. What happens if you're dealing with marks? So for marks, for example, marks extend from 0 to 100%. Do you want to create a chart, a tally chart with 100 entries in it to make sure you cover each one? No, the answer is no. What about height? Say you're doing height. Well, height could extend from, if you're going from a small child up, you could be looking at 30 centimeters all the way up to 200 centimeters. So are you going to have 170 entries in your chart? The answer is no, obviously. So what we need to do, we need to create intervals. We need to create intervals for the data. Okay, so there's only a couple of rules, or a couple of things to keep in mind when you are creating intervals. So for intervals, you must have intervals of equal size. Okay, you can't have an interval, say, that goes from 0 to 5, and then the next one 5 to 20. So 0 to 5, say 6 to 20, and then 20 to 50. Okay, that's not permissible. Okay, you need to have intervals of equal size. So you'd go 0 to 4, 5 to 10, 11 to 14. So there'd be 0, 1, 2, 3, 4. That'd be 5, 5, 6, 7, 8, 9. Whoops, that should be back. Fix that up. 5 to 9, 10 to 14, and etc. So each interval has 5 pieces of data possibly within that range. The second thing you have to have is that all data must fit. So you can't have a piece of data in the end that doesn't fit in your interval. So for the example I had over here, if I had an answer of -1, it doesn't fit in my interval. Okay, but that's something you look at the data and make sure everything is included. So how do you make sure you have intervals? So how do you determine interval size? So the rule of thumb is 5 or more intervals. 5 or more intervals. So if you have 5 or more intervals, that's going to give you a sufficient spread to do proper calculations. So for example, if you're calculating, so if I extend the page, what we would do, the formula then for interval size would equal max minus min over number of intervals. And now this is where you get a chance to play it somewhat smart if it works out for you. So for example, if max take away min was equal to 45, then when I'm doing the calculation, 45 divided by, and I need to pick the number of intervals, so the denominator, I want to pick something that A is bigger. Okay, if I scroll back up for a sec, okay, so the rule of thumb is 5 or more intervals. So I know the minimum number to divide by is 5. So in this case, does 5 divide evenly? The answer is yeah. We can put a 5 in there, and you end up with 9. So each interval size would be 9. So you would know you'd have 9 pieces of data in the first line, 9, and 9, and so on and so forth. If max minus min was equal to, let's say, 36, let's say, for example, looking at 36, I don't want to divide by 5 because it doesn't work evenly. It'd be nice if it divides evenly, and then if you pick 36 divided by 6, then you get a nice even number to work with. That's not how the world always works. You may run into a situation where you have no choice and you got to go with decimals. And if that's the case, then you pick the best possible decimal. So for example, if max minus min was equal to, let's say, 77, and you run through 77 divided by, and if you use the calculator here, so it's just a bit of a trial and error to decide what you want it at. So if we go 77 divided by 5, that's 15.4. That's not too bad. Divided by 6, I don't like repeating decimals. Repeating decimals are not a lot of fun to work with. 77 divided by 8, 9.625, that's not too bad. 77 divided by 9, back to repeating decimal, 77 divided by 10, 7.7. So you have the option of either using 5 or 10. It depends on what you prefer. So you end up with the 15.4, or 77 divided by 10, 7.7. And that just means this is what you're going to count up by. This is how much data is in each category. All right, so you're picking the one that best suits the situation that you're working with. All right, so into my final example then, so you get a chance to see how that works. So in this one, it's not something you have to think about a whole lot because you've seen this quite a bit all the way through your school career. So the example is the following is a survey of data management for you midterm marks. Use the given data to complete the following. So we want to create a frequency table. That's what we did in the first one. So at the frequency table, I'm not going to have the marks listed from 0 to 100. It would just be ridiculous and inefficient. So I know that marks are typically between 0, though they have to be between 0 and 100. Okay? So when you set it up, I know my intervals will be 0 to 9, 10 to 19. And what I'm doing here, because I started with 0, technically it's possible to have a mark of 0. And I want the categories to be even. So if you go from 0 to 9, that's 10 marks. So 10 to 19, 20 to 29, 30 to 39, 40 to 49. Make a little bit more room here. 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 99 to 100. So, oops, Try that again. Lost control of my counting skills there for a second. 90 to 99. Now in this case, you're going to say, well, what happens if someone gets 100? It's not covered. Yeah, in this case, I would have to extend it, and I would go, if there was someone that got 100, I would have to add in 100 to a 109 category, even though getting above 100 in our system, technically it's not possible. And then you set up your tally. So now you've grouped the data. You've taken 30 marks, I think is what I have set up in this example, and you've reduced the tally down to, say, 10 categories. It's going to be very helpful in the project part of the course. So I'm just going to shrink it and see if I can see all the data at the same time, and that's going to just work. So quickly going through, I have a 60 and a 50, 60 and a 50, 80 and a 60, 80 and a 60, 50s, two 50s, 80 and a 60, 70 and a 30, 80 and a 20, 80 and a 20, 70 and a 60, 40 and an 80, 40 and an 80, 40 and a 79. I got to be careful with that one because 79, no, falls into that category. I'm fine. 70 and an 80 again, an 80, 59 and a 68. So there's a 59, and the 68 goes to a 5. 99 and a 73, 99 and a 73, 76 and a 77, so two more in the 70s category, 50 and a 60, 50, and a 90 and a 60, a 90 and a 60. So now we've created a tally. Now we're back to where we were with that first example. So the first example looked exactly like this. We've now got the tally. So what you've done is you took a series of group data. Okay, so we've taken our grouped data from up here. We realized that we can't have an individual in the tally for each mark. So we've decided to create some groups, and the groups were the ones right here, our marks. Now, not everyone's going to look the same. If I gave this question to 3 different people, they might pick 3 different ranges, and that's fine. Does not matter because I got to mark it according to the way the person does it. All I'm looking at are the intervals equal value, and is there more than 5 intervals, and does all the data fit in there? Okay? I'll finish up this example in the next segment.